electrons traveling through neurons and dendrites. And so it's all the flow of electricity in a chemical balance. When you get mental health issues, a lot of times there's an imbalance in chemicals in the brain. Okay? Bipolar disorder, there's a lithium imbalance. And so it's treated with a lithium product to kind of get that balance in the brain. Okay? Many other forms of mental illness, they have different chemicals that can kind of help mitigate it or at least make it more mild, trying to get that balance. There are so many things in the human body that have to balance. I mean, from sugar levels and insulin, you know, that if that gets out of whack, you're either hypoglycemic or you're diabetic. If you're not getting those just right, even it's this breathing. The more we breathe, we have to exhale the carbon dioxide. If you breathe in too fast, then you get too much oxygen, you get out of whack, you pass out. You don't breathe enough, you don't have enough oxygen, you die. You know, so everything is a balance. All right, so the reality is, I can tell you everything revolves around chemistry. Chemistry is in everything, okay? It's in everything. Even in relationships, there's such chemistry between those two. You know, there's not earth science between them. Chemistry, essential science, that's the name of your textbook. It's a part of everything. That's why I think it's so interesting, because I want to understand how the world works. How do, you know, here's one of the great mysteries. How can hydrogen that's a gas and oxygen that's a gas combine together to make liquid water? How can that be? Now, we will learn the answer to that. It'll probably be a semester exam question. But note to self. You know, but you know, it's a great mystery of life. You know, why are some things solids and other things liquids and other things gases, and why do some things react with one another and other things not? How come the noble gases don't react with anything, whereas the halogens right next to it react with just about everything? How can gold, that's 79 protons in the nucleus, be a precious metal, malleable, and makes great jewelry, and just everybody wants to have as much gold as possible? And then you add one more proton, and all of a sudden now it's liquid mercury that's toxic, and everybody's totally afraid of it. One proton difference in the nucleus. That's what's so amazing. Okay, so now the way this works is you get a 5-minute break. So now you can go in the hall, you can go to the bathroom, you can't get water because the water fountains are all covered up. You can get on your phones and you can do all the things that you need to do. Okay, but this is just a 5-minute mental break. Okay, so then you get home, so you can play your video games for 5 minutes. I know you've been paying attention intently.
Right? Oh, wow, we did.
Well, this one is adult. I had a ham sandwich and then the back question goes to that, but Mountain Dew goes into fire. You all just don't come near me while I'm drinking this, and I don't come back.
I have a question. How are you coming every day?
That's the banner.
Good.
It's the banner.
Okay, really?
Yeah, oh yeah.
So like, what you do you come up with?
Yeah, they're letting teacher kids come 4 days a week. I wish they would make that an option for everybody.
But, you know,
I hate learning French, I don't like it. That's why I really wish I could do it.
I think the majority of people would pick 4 days a week, you know, versus the virtual. And that would make our numbers be so big, then, you know, we wouldn't be social distant and all that. So, number of teacher kids, minimal, so it's not gonna affect anything.
So are you the bowling coach?
I am the bowling coach. You're a bowler?
No.
Wanna be?
I don't know. I don't know. I'm a fan. I do too much fan.
Well, bowling isn't until after band season. Bowling starts in October, and I don't have a first match generally until November.
Okay.
So. But you come out and it's fun.
I've always thought it was happening.
But, yeah.
I thought it'd be like, hey, let's go do a bowling team. Looks like y'all are pretty good.
The first 3 years we were state champion.
Really? 3 years in a row?
Yeah, well, the first year it wasn't official, but we're doing it in Alabama and just claiming it as one, even though it wasn't official. But we were undefeated. We won every tournament and just,
Yeah.
we were by far the best team in the state. And then the next 2 years we won it when the first 2 years they had it. And then we qualified for state every year, but we haven't performed well at state. But last year we won the regional tournament, which was
That's
the
good.
top 16. Yeah, we beat Auburn in the finals by 300 pins, and then we came and played them first round in state, and they beat us by 150.
Wow.
I know. We bowled horribly. That ratio of mine, over here on the I do too. I know the country, that's why everybody left you. Let's go, AP Chemistry. Almost through day one.
It's so
Now,
cool.
don't you play any tennis with some?
Barely now, except for like work and volunteering.
Mm.
We were getting, I kind of figured like you don't wear masks when you play.
Yeah.
So I feel like comfortable going out. Because when clinic started up again in like May, I didn't want to go to my grandma's house.
Yeah.
I started playing with my family, but
All right.
cool inside confidence.
Like sweating.
It's almost just like every single time costume.
My room is usually pretty cold, but because if I get comfortable, then that means y'all are breathing. Okay. So I kind of shared with you what I think you shared with me, and we talked a little bit about chemistry. If I play a word association game, okay, I want you to clear your brain. I want the first PG rated or lower word that comes to your brain when I say this word is what I'm going to ask you about. So, okay. So here's the word. Everyone can clear all your other thoughts out of your brain. Here's the word. Chemistry. You've had a year of it.
Mr. Gruber.
Mr. Graver, he's the epitome of chemistry. What comes to your mind? Death? It's killing me. Chemistry's killing me. Hampton, what'd you get? Cool. Chemistry is cool with the CHO. Cool. All right. Carrie. Atoms. Okay. Now just know, never trust an atom because they make up everything. All right. Let's see. Is anybody who else still paying attention at home? Zane, did you think of a chemistry word? Are you still there?
I kind of thought of Mr. Graber as well.
He is the epitome of chemist, and so that is right. Okay. Let's see. Jaden, what do you think?
Atoms again.
Atoms. Okay. Grayson.
Probably atoms too.
Oh, yeah, come on, we can be more creative. At least somebody say molecules instead of atoms. And so, Angel.
Hobbs.
There you go. Somebody, I got to keep up with Gravers, you know. Paris.
I thought of Miss Guthrie.
Miss Guthrie. So, okay, so you guys are all associating the subject with the teacher, okay? But what we have to do this year is change that and get it to be much more internalized so you have your own concept of what chemistry is. I think I got everybody. Did I miss anybody? Anybody feel left out? Okay, good. All right, so that is what you guys kind of atoms. Nobody said periodic table. Nobody said explosions, you know, chemical reactions, all of those different things. Everyone wants to know what happens here, you know, how did that happen? And we'll see that relatively soon, okay? But I can sum up chemistry in 3 words: curiosity, creativity, and power, just raw power. So let me kind of show you a little bit of those 3 things. First thing I'm going to do is going to read a story. A story about a guy named Ira Remsen.
I think you need to move that.
I need to just go home. Golly.
This is not your day.
Yes, I'm not normally this bad, y'all. I really am not. I guess 6 months off, I'm way out of practice. Okay. So, Ira Remsen, this is a story this is an actual account from his journal. Okay, so I'm gonna read the story and reenact it, okay, as we kind of go through it, okay? So, Ira Remsen, he was an influential chemist. He lived from 1846 to 1927. He founded the first Center for Chemical Research at Johns Hopkins University. Okay, so he was pretty big time in the early chemistry world. The turn of the century, 1905, 1906, is when Einstein had all of his big breakthroughs and wrote his big papers on the theory of relativity. So tons happened between 1900 and 1920 in the world of chemistry, and Ira Remsen was right in the middle of all that. But this is his encounter for the first time when he just really got stoked about chemistry. So 1846 to 1927, let's assume he's 20 years old when this takes place. So 1866, what's happening in the United States in 1866? Civil War just ended. What's the major mode of transportation? Trains, but what else? That's trains. The Transcontinental Railroad we're still getting worked on. Horse and wagon, horse and buggy, right? This is the 49ers going west searching for the gold. That's wagon trains, cowboys and Indians. Okay, that, you know, if you've ever seen the Will Smith Wild Wild West, you know, it's just kind of that mentality. No electricity yet. So when he's talking about going to the doctor's office here, it's not like our doctor's office. I mean, it's probably just this wooden building with a lantern in it, wooden chairs and whatever, you know, a window. But there's no lights, there's no fans, there's no air conditioning. It's very, very, very primitive. Okay, so we have the setting. We got that picture. Do you guys even know what a Western movie looks like? Did anybody ever watch a Western? You need to go back and watch some Clint Eastwood, you know, the good, the bad, the ugly, some good old John Wayne movies to see what the West looked like. So here's his account of this. While reading a textbook on chemistry, I came upon the statement, nitric acid acts upon copper. I was getting tired of reading such absurd stuff, and I was determined to see what this meant. Copper was more or less familiar to me, for copper cents were then in use, as they are today. Yes, can you catch? Okay, can you read the date on that form?
1970.
Perfect. Oh, that's how you catch it. Okay, now, he went and set this on the table. We've learned a little bit, but just imagine you're in an enclosed doctor's office. He has a copper penny. And so he says, copper pennies were then more or less familiar to me. For copper cents were then in use. I had seen a bottle of nitric acid on a table in the doctor's office where I was then, quote, doing time. So even back in 1866, doctors made your weight. They could, if any of y'all ever watched Seinfeld, which you probably don't, but there's a whole episode, you can make a reservation, you just can't keep the reservation. Okay, so anyway, so he's in that room waiting for the doctor. He's read nitric acid acts upon copper. Now, I have no idea why a doctor's office would have nitric acid sitting out there. I have no idea what medicinal purposes, because this will just burn the crud out of you. It turns your fingers all yellow. I mean, it's just very strong stuff. And so, obviously, there weren't as many lawyers back then, because there's no way you could have that out today. I don't know about you, but when I would go to the doctor, especially when my kids, when they were young, my son's poster child for ADHD, when we go into the doctors and they're, you know, they say, doctor will be right with you. When we get bored and we start looking at all the drawers, you know, most of them are locked, but one's got some gauze in it or something. They leave the little reflex hammer out, you know, you kind of play around with it. You guys don't do that?
No.
Okay, the little otoscope on the side, you know, where you look in the ears and the nose and all that, I'd take that off, and it's supposed to have this little cap you put on the end for sanitary purposes, but those are in the lock drawer. So I would just be sticking that thing up in Tyler's nose and in his ears, looking and kind of seeing. Then you hear the rustling of the paper, you know, and you just kind of, you know, you put it back and you just quickly sit down and act like, hey, doc, what's going on? And so that's what I imagine is going on in Ira Remsen's mind. He's a young kid. He read nitric acid acts upon copper. He's got a penny. He puts it on the table, and he says, what does act upon really, really mean? So he takes some nitric acid, pours it onto the penny. Now again, this is taking place in a small enclosed space, okay? Hopefully you guys can see this bubbling. I'm going to do this for you guys tomorrow anyway. But it's bubbling. Down here, you got this brown gas being given off, okay? But what was this wonderful thing which I beheld? The scent was already changed, but it was no small change either. No small penny, no small change. It was a change, but no small change. No chemistry humor at the end of the first day. A gray colored cloud arose. Oh, wait a minute. A greenish blue liquid foamed and fumed over the scent and over the table. The air in the neighborhood of the performance became dark red. A gray colored cloud arose. So the whole doctor's office is starting to fill up with this red smoke. You breathe it, it gags you and makes you cough, and it's suffocating. It's very dangerous gas. Okay? Now, I'll just go another second. I tried to get rid of this objectionable mess by picking it up and throwing it out of the window, which I'd meanwhile opened. So now he's panicked. He opens the window, he throws the penny out, trying to fan all this, out. I'm sure that's right when the doctor walks in, because it makes it. Okay, so I'm not going to throw it out the window. Okay, notice it's greenish, kind of turquoise color. Okay, now it's same part fluid, go Jack. Okay? I tried to get rid of this objectionable mess by picking it up and throwing it out of the window, which I meanwhile opened. I learned another fact. Nitric acid not only acts upon copper, but it acts upon fingers. The point led to another unpremeditated experiment. I drew my fingers across my trousers, and another fact was discovered. Nitric acid also acts upon trousers. Okay? So he picks it up, throws it out. Oh crap, my fingers. He wipes it on the air, then he get a hole in his pants, his fingers are burned, he's suffocating and choking. But taking everything into consideration, that was the most impressive experiment and relatively probably the most costly experiment I've ever performed. I tell it even now with interest. It was a revelation to me. It resulted in a desire on my part to learn more about that remarkable kind of action. Plainly, the only way to learn about it was to see its results to experiments work in the lab. All of a sudden now, the word, the thing's killing me. I'm about to put it up here. So. The words act upon all of a sudden now mean something to him. It's not just words. I don't know if you've ever read a textbook and you go through the whole page and you say, oh crap, what did I just read? You know, especially when you're tired and whatever. So sometimes with things are mere words. We want to internalize everything. We want to figure out and really get a good understanding of what act upon means. Or when we talk about a chemical reaction, or we talk about thermodynamics and energy, exothermic reactions, endothermic reactions, where is the energy coming from? We want to have an understanding deep on the molecular level what's going on. Okay, so that's what we're going to work hard at, and I'll do a lot of demos to try and make it real. And when we do a lab, I'm going to try and really get you to be focusing in and thinking about what's really going on, rather than say, ooh, look, they're pretty yellow color, you know, but what's going on beneath that on a molecular atomic level. That's the goal, okay? Now, that curiosity, that to me is my motivating force. And it really, you know, people say that, you know, you take it because you just like chemistry and, you know, it seems like, you know, you just want knowledge for knowledge's sake, okay? Well, that's what drives me. It's just, I just love knowing how the world around me works. All right. So, the second word is creativity. This out of the way. My room was clean yesterday. I messed it up already today. Here's the pen. Now, one of our first labs, it's like the second and third lab, if we could actually do a lab, is we're going to do this same thing. We're going to dissolve the penny, but we're going to dissolve it completely. I'm not going to stop it. We're just going to let it go completely. But here's the penny, what's left of it.
It's clean now.
It's very clean because all the junk is just pure copper now, but we can kind of see that. All right, so the second one is creativity, using science to meet the needs of society. And let's just say that you have a pet elephant, or you know, you bought a zoo. You know, in their movies, you know, I bought a zoo, or I think there's like Brad Pitt or somebody did a movie like that. I bought a zoo. You know what I'm talking about? Thank you. See, I'm not crazy. All right. Oh, nice. Pause. Time out. I forgot I used. I might be enough. We'll see. Take exactly 100 milliliters of hydrogen peroxide. Perfect. Now, right now, that hydrogen peroxide is decomposing. Just super, super slowly. But if you ever look at a bottle of hydrogen peroxide, it says, store in a cool, dark place. Because heat from the air and light are enough energy to make the peroxide decompose just, and break down. That's why old peroxide, you pour it on your cut or your straight, it oftentimes doesn't do anything because it's completely decomposed. Okay? So it's reacting right now, but ever so slowly. But I need to make some elephant toothpaste because I bought a zoo. Okay, so we got to put some cleaning agent in there. Okay? And then, of course, for marketing purposes, we have to have a little color. So, we put a little blue, put a little yellow, use red, but I don't have any. A little green. Okay? But it's still not really working, it's still not going, so I need something to speed up a reaction. What do we call a substance that you add to make something speed up? A catalyst. So potassium iodide is going to be the catalyst. And so when wow.
Nice.
You guys have some kind of jinx. That has never, in 39 years, that has never happened.
Is that a good thing?
Yeah, but that's why I'm glad I had a face shield on.
Usually.
It just should come out and look like toothpaste. I mean, I'm sure you saw it last year.
Oh, yeah, it just comes out so easily.
How hot is it?
Oh, it's like burn your hand hot.
That's fine.
Yeah, especially probably down there. This isn't too bad. Now I'm gonna be here for a lot. That's what. Golly, that
All over that.
it's all over everything.
That was cool, though.
Lord help me. You guys don't want to stay back when I do my demos. I guess there was more potassium iodide in that bottle than I thought there was.
Probably.
Damn.
Sped it up a bit too much.
All right. So anyway.
This is why I love this class.
Hey, but that's one of the reasons why we have to have safety, okay? Because sometimes weird things happen, okay? And that's why goggles, most of the time, you don't need the goggles on. But on something like this, if you don't have goggles on and that hot peroxide goes flying up into your eyeballs, there's a chance I could be blind. Now none of it got on me. Luckily, because, my quick cat-like reflexes, I just went flying backwards. I'm sorry, Mr. Graver, I kind of messed up your box here. Okay. So creativity, using science to meet the needs of society. Now, I don't know if anybody's interested in doing medical research or pharmaceutical research, R&D, but one of the things that kind of fascinates me is the progression of analgesics, in other words, aspirin. Now, first off, does anybody know where aspirin originally, the source for aspirin or how it came about? Anybody ever hear that? Well, it's kind of a crazy far out way it came about. It's derived from a compound found in the bark of a willow tree. And so somehow or other, somebody was gnawing on a piece of bark. And they said, my toothache doesn't, isn't quite as bad as it used to be. Or, man, this made my headache go away. Or, just, I don't know who the first person was that tried the bark of a willow tree and know this, but aspirin came or is derived from that compound. Now, Bayer company in the 1850s, 1860s, changed that chemical into what we now call aspirin. Okay, so we're going to do a little bit here. Now, this is what I refer to as oh my information. You are not responsible for this. No, it will not be on the test. But if you look at this, anybody from AP Bio recognize this structure, this compound? It is a hydrocarbon. C6H6. This is known as benzene. Benzene is a known carcinogen. What's it done? Cancer causing. Okay? But this benzene ring, now, this is very difficult to kind of draw all the time. So scientists have figured out a shortcut way. That's supposed to be a perfect hexagon. And I don't think either of your teachers talked about the term resonance. Okay? But that's when this double bond can actually be kind of shared between the two. And so they just draw a circle just kind of showing that resonance. You assume that each vertex there's a carbon, there's always enough hydrogen then to make it have its 4 bonds. So this is called a Kukuli structure. It's just a shortcut way of drawing this. Okay? So when we look at aspirin, looks like this. Okay? And then the other side. Okay? That's what aspirin looks like. It's got the benzene ring, but because we've changed it now, it lost its carcinogenic effects. And now aspirin, which the scientific name for it's kind of fun, is acetyl salicylic acid. The salicylic acid is what was in the bark of the willow tree. But it was too strong, and it was really a very strong acid. So Bayer was able then to go and do this. But does anybody recognize this functional group, the COOH? AP Bio.
I know what it is.
Begins with a C.
Oxal.
Carbonyl.
Carboxylic acid. Okay?
Oxal?
And this is known as an acetyl group. Okay? The 2 carbons make the acetyl group. And so we have a benzene ring with 2 branches on it, but it's an acid. And as a result, it upsets your stomach. But it has 3 effects. It's an analgesic, meaning pain, okay? Gets rid of pain. Okay? It is anti-inflammatory, which is that's the inflammation that's usually causing the pain. And it's an antipyretic. What is that? Antipyretic. Pyro. What? Fire. So what's an antipyretic? In terms of medicine, though, what's it going to be? No, it's simpler than that. What do you take aspirin for? No, it's going to create heartburn because of the aspirin. You take it for a headache, but if you're sick, you're going to take it because it's going to do what? Antipyretic. Yeah, break your fever, bring your fever down. Okay? So they find that it has those 3 effects. Branch chain to a benzene ring with 2 branches on it, an acetyl group, okay, but it's an acid. So the Tylenol people came along and said, well, maybe we can modify this just a little bit and change it to where it's no longer going to upset your stomach. So Tylenol still use the benzene ring, but they put an OH group up here. And this compound right here is called phenol. So a benzene ring with an OH on it is called phenol. But we have to have 2 branches on it. And so to make it have the same effect, so when we look at the other side, and okay, here's your acetyl group again. But does anybody from biology remember when you have nitrogen? Okay, what the big long chains of these nitrogen and whatever make up what compound or amino acid? This is an amine group. Okay, whenever you have the nitrogen, that makes it an amine. Okay, so they still have a branch off of benzene ring, but they've changed it from being an acid to a base. Both the amine and the OH are going to make it basic instead of acidic. Okay, but we still have the acetyl group on here. Now, in doing that change, it's easier on the stomach, tougher on the liver. Easier on the stomach, but it's probably a little bit better pain reliever, better analgesic than aspirin. It's still antipyretic. Okay, maybe even a little bit better than aspirin. But they lost the anti-inflammatory action. Okay? And that's usually what's causing the pain. So the progression then goes to ibuprofen. So we go back to a benzene ring. Okay? And then let's move up. This one's much more complicated. Oops, move it. Okay, so we got our carboxylic acid group back on there, but they put this branch in between, and that weakens the strength of the acid. Okay, but we have to have two branches, so there's another branch coming off over here that's even more complex. That's going to be okay. So this is ibuprofen. Okay. Now, by the way, when we come back, the official name of this Tylenol is called acetaminophen. Okay. Acetaminophen. Okay. So there's actually a rhyme, or there's a reason to having the name acetaminophen. Tylenol is the brand name, but it's, you can buy generic. Acetaminophen is acetaminophen is Tylenol no matter what. Okay, so and then ibuprofen. I don't know what the official name of ibuprofen, but it's again, it's all just two branches. Brought the acid back, so it's a better pain reliever. Ibuprofen's a great pain reliever. It's good fever reducer, and this having the acid back in here in the branch brought the anti-inflammatory back. Now, I still think that aspirin is a little bit better anti-inflammatory than ibuprofen, but this does have the anti-inflammatory action. Okay, so that's just kind of as you go through. This is what medical research. Now, how did they go from here to here and the test? And probably a bazillion wrong things happened before they got it right. Okay, but that's what a medical research, just in a very simple sense, is going to do. Yes, sir.
So did the carboxylic acid make the benzene non-carcinogenic, or?
Well, it's just any branches on it, to help take away and change the properties of the substance.
All right.
Okay, so whenever you do a chemical reaction, you make a new substance, it's going to have its own set of
I'm
characteristics.
asking, it's not the reason it's non-carcinogenic.
Well, I don't know. I don't know what it is about the benzene ring that affects the cells versus how that doesn't. I don't know, maybe it's the acidic basic nature changes how it interacts with the cells. I am not a doctor or biochemist of any biochemist of any way. But I just think that as far as creativity of using science, going through and trying to figure out, okay, how can I make this better? What can I do? And there's so many, I mean, in the processes and chemical plants, You know, it's constantly, how can I make this reaction more efficient? How can I, make it better? Okay? So, that's just, for me, the curiosity aspect. Now, the fun one is the power. I think we're gonna need to print out a new one of these. What do you think? Is this paper hot? Paper hot? I mean, you just touch it. Okay. No, I mean, it's just normal paper, right? So if I do this, where? You want to touch it now? I'm talking about in the fire. Where's all this fire? Where's all the heat coming from? The paper wasn't hot. How are we generating all of this heat from nothing? Chemistry, that's exactly right. And so, trying to understand the thermochemistry, trying to understand where does the energy come from or go to. Sometimes the reaction gets cold. Now that one gave off heat, therefore it is endo or exothermic. Exothermic, if something gets cold, like a disposable ice pack for in a first aid kit, you mix them together and it gets cold, that's going to be an endothermic reaction, okay? And so as a result, you know, why are those energy changes? What's happening? What's going on an atomic molecular level to where is that energy coming from? We're going to spend a lot of time talking about energy. Now, I don't know if any of y'all have ever made a potato gun, okay? A potato gun's a PVC pipe. You have just a little place where you can put some fuel down into it, and then you can use a little like barbecue pit, those piezo lighters that just make a spark, and it shoots a spark across, ignites it, usually it's hairspray or some kind of alcohol spray, and then the potato goes flying out and it can go the length of a football field or even farther, okay? This is my version of a potato gun. I got 2 nails in here that are separated by about a 1/4 inch gap. Yeah, I have a rubber stopper in here, and I'm going to put a little bit of fuel. Do I have any fuel still in here? Yeah, I do. So I'm going to shake this up. You got crap all over this. Wow. I do wish we were recording that. I always like to have seen that in slow motion. Okay, so I shake it up because we want vapor, because vapor is going to burn faster than liquid because of the surface area. Okay, so now if you're going to shoot a gun, you got to have a target. Okay, and why don't you come sit right back over here? Not that it's going to go that way, just the ricochet when I miss. It's not going to be good. So, doesn't matter where I aim, I'm going to miss. So we need a spark then to ignite it, just like the spark plug in your car ignites. Okay, so when I go and make a spark, okay, okay, so when I go and I touch across here, makes a spark, the alcohol vapor inside should ignite to the core cap. The rubber stopper is not a core. Okay, you ready? And it makes a boom. That's why I didn't move.
Where did it hit? Like the wall behind it?
Okay, so we'll try it. Okay. Yeah, I like it. I purposely don't warn you about.
I was like, what?
Okay, so now, does anybody know when a hydrocarbon burns? Methanol is a hydrocarbon, CH3OH. When any hydrocarbon burns, what are the 2 products always? Come on, everybody learned this last year. Say what? No, it's not oxygen gas. not just carbon,
Water.
carbon dioxide, and water. Anytime a hydrocarbon burns, the gasoline in your car, the propane on your grill at home, you know, and so any hydrocarbon that burns produces carbon dioxide and water. So this bottle is full of carbon dioxide. So I got to get some fresh air in there, well, relatively fresh. Okay, all right. Plus I need to cool it off because hot gases don't expand. It's got to go from cool to hot to make it expand. But now I don't even have to add any more methanol to it. And so amazingly, I mean, I had 1 milliliter to start with, and I've used it now 3 times because I used it in the other class. All of that power, less than a milliliter of methanol. Shooting high, shot left, and aim it a little bit more over there. I think it comes out left. See if you can, that's way left. See if you can see where it hits. I guarantee it's not going to hit the ball. Yeah, you can cover your ears. You know now it's going to make a move. You ready? Here we go.
Oh, it was way up.
What's up?
It still scared me. It was like way up.
All
It still scares me.
right.
Chemistry.
All right. This is the way modern. This is in our everybody gets a trophy mentality. You don't can't hit the target. Just
It can't miss now.
We're going to see this box case. I'm probably really.
Can I record it?
Okay, so I'll turn the lights off this time, and you see the fireball come out.
Fire. Remember that?
Oh, there's a big old fireball coming out. All right, we ready? We're rock and rolling. Lights, camera, action. Here we go. Off to the right on that. Okay. Again, I still haven't added any more methanol to it. Came over here somewhere.
Oh, I didn't see the fireball at first, but I saw it in the video again.
Yeah, I mean, it's a big fireball. Anybody see the road stopper? I thought it came this way.
It's after.
Yeah. You can tell me.
There. Look. Wow.
Now, I know that you're going to find this very hard to believe based upon the activities, events of today already. But the first time I did this, I didn't have one of these. I didn't think we had one of these. It turns out we did have one, but I didn't know where it was at the new school I was at. I tried to make one out of a power supply. Power supply generates 15,000 volts. Okay? So I had one wire here and I touched the other wire there. Well, somehow or other, instead of the electricity going that way, it went straight through me. Okay? Felt like somebody hit me on the chest with a sledgehammer. And my classroom was an amphitheater style classroom. It took me down. Okay, I'm in my 20s when this happened. Okay, of course everybody's laughing and whatever. I'm trying to do it. Okay, so finally I find one of these and I do it right and it's all great and I remember. So the next year I said, oh, I'm going to do this when I got it now, but I didn't read the directions. I know, typical guy. And instead of using 1 milliliter, I used 10 milliliters. I thought it was 10 milliliters. And I didn't have this type of ring stand. I had one more like this. It's actually even smaller than this one, where it hooked up to it, okay? When that thing exploded, it went flying out. This whole thing caught on fire. This went backwards, and I had a window on the other side. I guess I should have run the directions one more time. Anyway. Okay, so now, hang on your phone, where did I miss it, right?
Wait, I don't know.
It looks like to the left.
Again.
Okay, well. All right, last time.
Fifth time.
This is like 5th time.
Yeah, fifth time.
There we go.
No,
Too high.
It was the fifth time we went to.
You done final line?
Yeah, I thought it was.
No, you didn't go high. I kept